Okay, hello everyone. Welcome to Concordia University's Space for the next installment of our Closer Look series, where we take a closer look behind closed doors and into spaces and projects that you might not know about at Concordia. And today, Space takes a closer look at the Dr. Ann Research Lab. And just to help situate you, we are streaming to YouTube live from Concordia University, and we are located here on unceded Indigenous lands in Tiohtià:ke, Montreal. At Space, we work with our university community to help mobilize knowledge by co-creating daily activities that examine research questions, projects, things happening across the university. We're hosting this as a live streamed event, both from here at Space and on location. So things might happen. Video connectivity issues, that's to be expected. But please stick with us as we show you around. We're also running this event as a live stream Zoom meeting, so we welcome any comments or questions via the chat. And those of you here in the space, if you have any questions, just raise your hand and we'll bring a microphone over to you. Okay, it's very much my pleasure now to introduce PhD candidate in the Department of Building, Civil, and Environmental Engineering at the Giannicotti School of Engineering and Computer Science, and our tour guide for today, Huifang Bi. Huifang.
Hi, Douglas.
Where are we?
Yeah. Oh, we are now in lab. Welcome.
Amazing. Okay, we're going in.
Yeah.
We've got our Space team, Birdie and Isa. Isa's on the cameras walking us through.
So where's the Ann Lab located?
It's located in EV building.
Oh, great. So
Yeah.
we're right downtown.
Yeah.
What floor are we on, Birdie?
12th. Oh, sorry. Okay.
Oh,
What?
12th floor.
Yeah.
Okay.
12th floor. Yeah.
Okay. Go ahead.
So we're
Yeah.
curious
Hello.
to see kind of, hello.
Hello. Yeah.
Curious
so
to-
what do you do here?
Okay, I am here for study and to conduct one of our research project on using the hydrogel coating, which can be deployed on the shoreline substrates and for effectively oil removal and prevention during oil spill response.
Oh, so
Oil
Oil
spill
spill.
response. Okay.
Yeah.
And how do you go about doing that, Huifang? What kind of?
Okay, I got it. And since when as long as the oil spills, the first study objective is usually the spilled oil, right? So firstly, I will introduce the one instrument. It's called the viscometer. It's used for the measure of oil viscosity. Since one of study objective is the spilled oil, knowing the oil characteristics is really helpful for us to understand the oil fit and behave in nature environment. We will use this instrument for viscosity measurement. Yeah.
great.
So
So-
you.
Yeah.
So you check the viscosity of different types of oil, different scenarios that might happen
Yeah.
in real life with, okay.
Yeah.
And then what
And,
happens?
So you mean for testing procedure or the next step? Oh,
The
for the
next
next step.
Yeah.
Okay.
Next step, sure.
Yeah, since our project is tried to remove the stranded oil from the shoreline substrates. Okay, for next study objective will be the shoreline substrates. And we develop an innovative coating approach for this kind of shoreline substrates for the effective oil removal. And here I will show you the gravel. And in our project, we use the gravel as the representative shoreline substrates. There are two types. And the first one, as you can see, this is the nature one, which called the pristine gravel. And the other one is the hydrogel coated gravel. We prepared the coating on the substrates. There isn't much difference between the two gravels. However, if you look really closely, as you can see, and you will find this gravel on the outer surface, there will have a coating, which I prepared days ago. It composed of alginate, cellulose, as well as nanoclay. Yeah, just for these two gravels. Yeah.
And that's to simulate the gravel would be the substrate that would potentially get covered in oil during a spill, and then you're adding a coating to see how it reacts with a coating?
Yeah.
Okay.
Yes. Since we have two types of gravels, we want to know their difference in the oil removal capacities by some testing in experiments. As you can see, we put the coated gravels and the pressed gravels at the testing vials, and then applying the dyed engine oils on the gravel surface to simulate the stranded oil on shoreline substrates. But in our test, we usually use the crude oil, which is related to the real situations. However, here for safety issues or also for better demonstration, we use dyed engine oil also, for the spilled oil. And then we will add the synthetic water. We use the DI water. Use synthetic water to the testing vials. Well, I will add 15 milliliters in total. Okay, I will take another one, and you will say. Okay. We simulated the stranded oil on gravels contacted with the water. Now we will cap this vial.
Okay.
Okay, to make it not spilled out.
Right. You don't want your own spill.
Yeah. Yeah, as you say.
Right.
And we will taking the washing process. For simplicity, I just manually shaking the vials.
Okay.
We will see some oil distributes in different ways. As take the coated gravels, for example, as you say, some oil will float to the water surface, and some oil dispersing into the water column, and there's still some oil will remaining on the gravel surface. But in our test, we usually use this instrument for taking the washing process, because this instrument can provide the comparable magnitude of wave actions in nature environment. And we also can adjust the environmental conditions and also adjust the operating conditions like washing time. And I will open the instrument. As you can see, we can fix our testing vials and the testing flask on the shaking tray. And
So with
Yeah.
this instrument, if I'm understanding this correctly, Huifang, with this instrument, you're able to simulate how the water moves inside of each vial to mimic how it would happen in natural processes, how waves might move, etc.
Yeah,
right?
yeah,
Okay.
exactly.
Okay.
Yeah.
Got it.
Yeah. Okay. Yeah. And then after this washing processes, and as I mentioned, the oil will go to different directions, right? So for now, we want to do quantification for these oil parts. For example, for the floated oil, we will use the oil absorbing pad to collect the floated oil on water surface. And the pad can quickly absorb the oil, but repel the water molecules. Yeah.
Okay, then
As you said.
you can see how much oil has been released that way.
Yeah. We can determine the weight of floated oil. And for oil dispersing into the water column, or for the oil still remaining on the gravel surfaces, we can use the organic solvent, let's say the hexane, to extract the oil into the water from the water or from the solid gravel. And then we will use the instrument of UVS spectral photometer for the oil quantification. And for determining the, firstly, we will build the calibration curves between the light absorbance with the concentration. Once we know this kind of a relationship, we can easily determine the oil concentrations of our samples. Yeah.
Wow, that's great. And is there a difference between how you simulate the movement versus like a river motion versus like an ocean that's really turbulent? Do you do different variations of how the water is moved in the vials also?
In our project, we mainly focuses on the simulations of wave actions in marine environment, not a river, because there is a huge difference between the two. Rivers usually have a very small wave actions, even no wave actions. But here in our project, we focus on the marine oil spill incidents, focus on the coastal areas. So we want to just simulate the comparable magnitude of wave actions in marine environments. Yeah.
Specifically marine environments. Okay.
Yeah.
So once you've used the machine and you've kind of created the same environment that the oil would see, the substrate would see in a wave situation in the environment, you're then now talking about testing the oil that's left.
Yeah.
After we've taken what's off the top, we have two ways to test what oil is left, and this is the first one that you're talking about right here.
Yeah. The first we use the UV visible spectral photometer. Now we will talk about the second way for the oil hydrocarbons determination. We can say it's another instrument is called GCFID, and its full name is gas chromatography flame ionization detector. It's a little bit complex, and we can say here this instrument, and we still will put the oil in organic solvent in the GC vials, and then the GC vial will be put into the sampler tray, and put into the sampler tray. When the system is a small amount of will be injected into the systems, and then the injected sample will be vaporized and enter the GC columns, and to do the separation processes, and then these separated components will be detected and finally converted at chromatograms. As you can see, in the chromatograms of our samples, it shows different peaks which corresponding different oil components, and the peak height or the peak areas is proportional to the oil concentrations. So again, we can build a calibration curves to determine the oil concentrations of our samples. This is the second oil quantification method. Yeah.
Okay. And that method allows you to do more at once. You can do multiple samples all at one time.
Yeah.
Yeah. Okay.
We can go to the next equipment, right? Yeah.
Let's go.
Yeah. And okay.
Just a recap for those of you at home. So we learned about the oil, and then we've put some oil and some water and substrate. We've taken the oil off the top, and then we've had two testing methods, one through UV and one through breaking down the oil into different components itself. And that's what's kind of determining how much oil is left. And then those are the two ways that they test that. So now we're at our next step.
Yeah, and the next instrument I will show you is the shoreline tank simulator. As you can see, I think it's a really great tool for us to understand the tidal effects on the oil migration and the distribution within shoreline. In the previous testing procedure, we tested the effects of wave actions, but we use this instrument just to investigate the tidal effects. As you can see, the test chamber, and it composed the whole system is composed of the testing chamber, the pumping systems, and the water storage and the distribution unit, as well as the custom designed software.
Okay.
Yeah, and so in our test, okay. Yeah, in our test, we will build an artificial beach by using a sand and gravel, which will be directly exposed the tidal cycles. And then I will excavate a pit for the contaminant, the oiled gravels, as you say, the dyed engine oiled gravels on the beach. And after that, I will simulate the tidal cycles by adjusting some parameters like the tidal cycle numbers, tidal cycle time period, and the water levels in high and low tides through decreasing and increasing the water. The pump parameters to change the inlet flow or outflow. As you can see,
Oh, I think we lost Huifang there for a second. Let's hold on. Oh, I had a question too. I hope we get back. Force Space team, I can see you. I'll just send them a message. Hold on with us, everyone. We're going to reconnect. We're reconnecting. I think we're coming back.
Oh, I think you
We're
got
back.
us.
Yep.
We're back.
Yeah. Okay.
So can you see, we just left off at, I think, let me know if we're
Artificial
missing
beach.
anything. We have, and we have some oil that you can kind of see that red substance at the top. So it's already working.
Yeah.
I had a question
Yeah.
about the artificial beach. I'm just curious, is there a way, are you modeling different types of beaches? Is there a location in mind when you create the situation in terms of what the settings are inside the artificial beach? Are you imagining a location?
You have a specific location when you're changing the different settings.
Yeah, we do have the specific locations. We usually use this kind of approach in the bedrock shoreline or the rock shoreline, not suitable for the sand shorelines, because the sand is very hard for coating. Even the sand is coated, it's easily moved by the effects of tidal or the wave actions. Yeah.
Okay.
Yeah, and when the is increasing water levels, we use the pad to collect the floated oil. So when the water reaching the lowest level, we will do the sampling analysis by taking some samples in the initially oiled areas to see how much oil is still remaining on the initially oiled areas. And when all the tidal cycle finished, the whole artificial beach should be sacrificed for stratified sampling, because we want to know the overall subsurface oil distribution. And as you can see, there are some marks I did previously. It shows different beach layers, and at different beach layers, we have a different sampling point. And also, if you look from the top view, there are also 2 or 3 parallel, beach layers. So in this way, there will be over 100 sampling points to determine the oil distribution. And I will show the figure for the comparison by using the pristine or coated gravels. as you can see, darker red means a high oil concentration. Control means we use pristine gravels. So compared with the pristine gravels, using coated gravels can significantly reduce the oil penetration. Yeah.
Yeah. And so this would become with these the coatings, Huifang, the idea is that the coatings would then be applied during an oil spill, during a crisis moment. These coatings could be added to try to reduce the amount of oil that's absorbed so that it's easier to collect.
Yeah, that's really great, because in real oil spill response, the oil spill responders always like the oil floated to the water surface. In this way, they can easily using some physical methods like skimmers or booms for the oil containment, and this kind of oil will be further collected and then recovered. That's the reason why we usually try our best to remove the oil from the shoreline and make them into the water surface. Yeah.
So again, like if you look at these rocks, Doug, like they're placing this coating on the gravel at the bottom, but it's causing all of the oil not to be attracted to the bottom, but to float to the top.
Yeah.
Okay.
Yeah.
It seems very. Huifang, I have a question for you.
Okay. Yeah.
I'm always curious to know how researchers choose the field of research. How did you become interested in this type of research, this type of work?
Okay, so actually, when I start my master degree, master program at Concordia, my direction is oil removal from the shoreline substrates by using chemical surfactant or using some other washing agent. Then I found it's really, really difficult to effectively remove the stranded oil from the shoreline, especially for the highly weathered oil. Then one day, one thought come to my mind. I think instead of removing the oil from the solid gravels, it's better to prevent oil adhered to the shoreline. So in this way, the oil will be easily collected, and we cannot, we don't need to use that chemical surfactant or use the other complex methods. Yeah.
Makes the cleanup simpler and cleaner, I imagine.
Yeah.
Have you ever been to a site to an oil spill? Have you seen an oil spill yourself?
Actually, most of our work just based on the lab scale. I did not go to the lab site. But when I was in high school, my hometown is also a coastal city. There will be there was a large spill incident occurred, and I was really shocked, and I really impressed us. That's the reason why I want to study the oil spills. But in the future, I think we will testing these facilities in the field test by using the real shorelines and simulating the real incidents. Yeah.
Yeah, it seems necessary. The next step. Huifang, this has been so fascinating. I think there's probably a lot more that you could show us, but I really appreciate you taking the time here to walk us through the lab. We're going to say goodbye here from ForceBase, but it's been really exciting to see like a closer look into what's happening, and I really appreciate your time. For those of you who are joining us here in the space, we're going to be closing up our Zoom and our live stream right now, but just want to let you know that this lab walk remains available on a closer look on our YouTube channel, so you should revisit it and share it. And Huifang, have a great afternoon, and thank you again.